Hi, my name is Dan Blainer, a solutions architect with AWS, and today we're talking about how to innovate with blockchain and ledger technologies on AWS. We've talked to many of our customers about blockchain. We've been interested in finding out how they plan to use blockchain and how we might help them to make that easier. As we talk to those customers about their use cases, we realize that there are two types of customers with respect to blockchain technology. The first set of customers want a system of record, also known as a ledger. They want this ledger to be owned by a central authority, and they want it to be immutable and verifiable. Perhaps they face regulatory scrutiny or audit scrutiny, or perhaps they need an unassailable audit history of their transactions. For example, consider a Department of Motor Vehicles, or DMV. They have a current record of all the vehicles in the state. They also have the historical data of all vehicles and driver registrations. They are the trusted authority for that data, but want a better way to ensure the integrity of their data. For these customers, AWS created Amazon Quantum Ledger Database, or QLDB. QLDB is a first-of-its-kind, purpose-built ledger database. It is composed of two main components. First is the immutable journal, which is a cryptographically verifiable log of each transaction. The second is the current state and indexed history, which stores the current value and historical state of the data. When application data comes in, it gets logged to the journal first, and then it gets materialized into the tables and indexes. The second set of customers want to transact with peers in a decentralized way without a centralized authority. For example, financial institutions want to do peer-to-peer transactions, but they want an independent way to verify transactions. Supply chain customers, these are complicated supply chains with retailers, distributors, and suppliers, and they all want a single view of the data. And then there's mortgage lenders. They want to run loan transactions without a centralized authority or middleman. For these customers, we created Amazon Managed Blockchain, a fully managed service that makes running blockchains on Hyperledger Fabric and Ethereum easy. With Amazon Managed Blockchain, you can create your network in minutes. Inviting other members to the network is easy and programmatic. You use the proposal APIs to invite others. Adding nodes is also easy. A range of node types are available depending on your transaction throughput requirements. Once your network is set up, you can build your smart contracts and applications and start transacting. With Managed Blockchain, you can get to this state in minutes. There are no databases to set up, Kafka nodes to provision, containers to build, none of that. Let's dive into some blockchain fundamentals. A multi-party business needs a way for everyone to independently verify transactions. Everyone in a multi-party business needs to look at the same data, and they need assurance that the data is tamper-proof. Today, customers are using either a central authority to share the data, or they engage expensive escrow services, which leads to inefficiencies. Blockchain builds trust in a network and eliminates the need for central authority. It has three main components: the distributed ledger, consensus mechanism, and smart contracts. Together, these components provide immutability and trust, and they enable multi-party transactions without a centralized authority. Blockchain is based on a distributed ledger. This ledger is where the current state and historical values of the data are kept. The ledger is an append-only, immutable, and cryptographically verifiable log of all transactions in the network. The ledger is distributed to all nodes in the network. All members in the network have the same view of the data. Next is the consensus mechanism. The consensus mechanism is how a network agrees on transactions that occur in the network. Different blockchain frameworks have different consensus mechanisms, such as proof of work and proof of stake. The consensus mechanism chosen impacts the network's transaction rate, the energy consumed by the network, hardware requirements, and security. And finally, we have smart contracts. Smart contracts are the business logic components that reside on the blockchain itself. These are applications that write to the ledger. Smart contracts can interact with components outside of the blockchain network, allowing you to integrate the blockchain with your enterprise systems. There are challenges with existing blockchain solutions. First, setting up a blockchain network is hard. You have to stitch together a lot of infrastructure to get one going. Blockchain networks are hard to scale. Think about the process required for adding more members and growing the ledger. Managing blockchain networks is not easy. You have to manage security across the network, governance among all members, data, and billing for all the infrastructure. And it is expensive. Customers often use consultants to build their blockchain story. To help customers overcome these challenges, AWS created Amazon Managed Blockchain. Amazon Managed Blockchain is a fully managed service that makes it easy to create and manage scalable blockchain networks using popular open source frameworks, Hyperledger Fabric and Ethereum. Amazon Managed Blockchain is fully managed. You can create a blockchain network in minutes. It supports a variety of open source frameworks, including Hyperledger Fabric and Ethereum. It is decentralized, allowing you to democratically govern your network. It is reliable and scalable, and low cost. You only pay for the resources that you need. And Managed Blockchain integrates with other AWS services. Setting up a blockchain network with Amazon Managed Blockchain for decentralized trust is easy. You create your network, invite members, add nodes, and then deploy your applications. So who owns the network? We get this question quite a bit. Networks are decentralized, and they can outlast the creator of the network itself. Members vote to invite and remove other members and configure network rules. Each member pays for their own infrastructure resources. Amazon Managed Blockchain is reliable and scalable. Hyperledger Fabric itself is built to be a pluggable framework, and we've replaced two of the primary services in Fabric with components that are optimized for AWS. First is the ordering service. The ordering service is a core component of Fabric that guarantees the delivery and order of transactions. The open source version of Fabric uses Apache Kafka for this component. Amazon Blockchain uses the same technology that QLDB is based on, increasing the durability and reliability of the ordering service. Amazon Managed Blockchain also uses a different certificate authority. The open source version uses a soft HSM, whereas Amazon Managed Blockchain uses AWS Key Management Service. So let's talk about a few of our customers that have used Amazon Managed Blockchain. Nestle built a supply chain asset tracking smart contract to track single origin coffee from farm to customer on an Amazon Managed Blockchain network to capture events as the coffee moves through the supply chain. This provides customers with visibility into the origins of their coffee. Nestle will use this as a platform to expand capabilities to other products. Sony Music Entertainment Japan is using Amazon Managed Blockchain to track music rights, improving the processing of artists' rights. Legal in General built its pension risk transfer ecosystem on Amazon Managed Blockchain. The blockchain has replaced manual processes and adds security to the entire reinsurance process. Now let's talk about Amazon QLDB. QLDB is a fully managed ledger database that provides a complete, immutable, and cryptographically verifiable history of your transactions. QLDB gives you immutability. All data changes are written to an append-only journal. They cannot be changed or deleted. Data in QLDB is verifiable. Your data is hash-chained on the journal, much like a blockchain. Data history is transparent. You can query and analyze the data lineage and history and trust that it is accurate. And QLDB is fast. It scales with your application and performs with very low latency. You don't need to trade performance for verifiability with QLDB. And it's easy to use. You query your data with a SQL-like query language called Particle and build applications using drivers in a variety of popular programming languages. This is an example of how QLDB works. Like any other database, your application will write data into QLDB using a driver. When data is written to your ledger, it is first committed to the journal. The journal provides immutability and verifiability by storing a log of each transaction in a sequenced way using cryptographic techniques. It is then written to the current state and index tables, which, as the name suggests, stores the current and historical values of all of your data. Now let's start diving a bit deeper into why you might need a purpose-built ledger database. Ledgers are not a new concept. For thousands of years, record keeping has been a central theme to civilizations around the world, and they have had to deal with the same kinds of problems that we deal with today. Traditionally, ledgers have been a book or other collection of financial accounts of a particular type. Today we see ledger applications used not only in financial cases, but any situation that requires any type of system of record. Many customers ask, why can't I just do this with my relational database? And the answer is you can. You can create audit tables and set up triggers to send data to those audit tables. This requires a bit of work to set up and maintain. Database administration tasks like restores can potentially corrupt the audit tables or disrupt those triggers. But finally, there is always someone with sufficient privileges to change the source data or the audit history itself. This can be critical if you're facing regulatory, legal, or audit scrutiny. Some customers try using blockchain frameworks as a ledger, but blockchain networks are meant for a different purpose. They're designed to operate in a limited trust, peer-to-peer network architecture. There are a lot of moving parts in a blockchain that help it operate in that environment. If you don't need that functionality, then there's no sense dealing with the operational complexity that it brings, so a centralized ledger makes more sense. QLDB is immutable thanks to its journal. Because the QLDB journal is append-only, it keeps a full record of all changes to your data that cannot be deleted, modified, or overwritten. There are no APIs or other methods to alter any committed data. This enables you to access and query the full history of your ledger. QLDB uses cryptography to create a concise summary of your change history. This secure summary, commonly known as a digest, is generated using a SHA-256 hash function. The digest acts as a proof of your data's change history, allowing you to look back and verify the integrity of your data changes. You can use this digest with QLDB's API to prove the integrity of any transaction. Verifiability is useful for business scenarios where you need to prove the integrity of a transaction. For example, an e-commerce business may need to show proof of a winning bid. A financial institution may need to prove a specific transaction against an account, or a biotech company may need to prove that a sample's data hasn't been altered. Some may ask, why does immutability and verifiability matter for a database? There are several reasons. Number one, to reduce risk, to safeguard critical system of record applications where data loss could be expensive. To improve data tracking, immutability helps you track your data's entire lineage. And because it increases the efficiency of audits and expands your audit capabilities. And because building immutability and verifiability in a traditional way is time-consuming, complex, and expensive. QLDB provides ACID-compliant transaction processing at the serializable isolation level. The serializable isolation level provides the most concurrency protection, eliminating the potential for phantom reads, non-repeatable reads, dirty reads, and write skew. The serializable isolation level is available in relational databases, but it incurs a significant performance penalty. Due to the nature of QLDB's journal, QLDB is able to provide this highest level of concurrency protection with no impact on performance. QLDB is serverless and highly available. The service automatically scales to support the demands of your application, and you don't need to provision instances or capacity. Multiple copies of your data are replicated within an availability zone and across multiple availability zones in an AWS region. You query your data in QLDB using Particle, a SQL-like language that is data format and data store agnostic. Particle enables unified query access across multiple data stores and data formats by separating the syntax and the semantics of a query from the underlying format of the data or the data store that is being accessed. It enables users to interact with data with or without a regular schema. Particle naturally supports nested data with an easy syntax that does not require extensions or functions to access those nested elements. Particle is not a new language that is specific to QLDB. Particle is currently used in S3 Select, in Glacier Select, and in Redshift Spectrum, and now in QLDB. With Particle, you can query data in a relational database, a non-relational database, a data warehouse, or even in a Parquet file sitting in your S3 data lake. Let's talk about how BMW is using QLDB. BMW wanted trustworthy vehicle data to share across multiple entities, including repair shops, insurers, and government entities. So they built the BMW Digital Vehicle Passport app to provide a complete and transparent history of vehicle operation and maintenance data. The app uses QLDB to provide an immutable history of vehicle data with centralized trust. Here's a graphic depiction of the application. In the middle, you can see different types of data being stored in QLDB, including vehicle maintenance data, the car sale data, and maintenance data. That data is available on a mobile application and is shared with repair shops, insurers, government entities, and other third parties. The Driver and Vehicle Licensing Agency in the UK is also using QLDB. The DVLA is responsible for the registration and licensing of all drivers in Great Britain and the registration and licensing of all vehicles across the United Kingdom. For issuing photocard driving licenses and vehicle registration certificates, and for collecting vehicle excise duties. DVLA's goal is to get the right drivers and vehicles taxed and on the road as simply, safely, and efficiently as possible. The DVLA faced several business challenges. Other government departments want driver data to support enforcement functions or as part of other initiatives, often linked to identification and verification. There are also many new vehicle initiatives such as clean air zones, parking permits, and car sharing schemes that they need to support. DVLA's core systems of record are typically many years old and built on traditional relational database technology. This means the data has a rigid schema that was defined a long time ago. Here we have DVLA's existing application design. This works well, but it has a few challenges. They have to manage and maintain all of the underlying infrastructure. It uses RDS, which is not inherently immutable, so you must be very careful about managing access permissions. And they have a separate write model and read model and an event handler developed to populate the current state with the read model. And this slide shows the future state architecture that utilizes QLDB and provides DVLA with some significant benefits. QLDB provides both the write model with a journal and the read model representing the current state in the materialized views. The journal is immutable and verifiable. There is no superuser or admin rights that permit modification of committed transactions. QLDB is queried using Particle, a SQL-like query language, and data in QLDB is stored as Amazon Ion documents. Amazon Ion is a superset of JSON. Both Particle and Ion are very familiar to DVLA engineers, making QLDB very easy to use. DVLA publishes changes to their data via Kinesis data streams that can be picked up by consumers and materialize the changes to downstream systems. This also allows them to replay events. And with this architecture, there are no servers for DVLA to manage. QLDB now offers a streaming capability that allows you to publish new transactions against your ledger to a Kinesis data stream. You can use this feature to drive event-based applications, perform real-time analytics, and to flow data from QLDB into other purpose-built databases to support analytics, reporting, search, and other access patterns. QLDB guarantees at least once delivery of data into the stream. You can start a new stream from any point in the history of the journal and replay transactions into the stream. Thank you for your time today. Please let us know how we can help you build your blockchain and ledger applications using Amazon Managed Blockchain and Amazon QLDB.